All right, can everybody hear me okay? Let me know down in the chat box if you can hear me okay. Awesome. All right, we're getting up and rolling here. While we're getting set up here, everybody let me know where you're listening in from tonight. Let me know in the chat box below. All right, we got people from, let's see here. I saw Van City. I thought it said Vatican City. I was like, wow, that'd be a first. Let's see here. We got North Carolina, Long Island. Let's see here. Minnesota, Aussie, Dallas, Texas, Miami, Washington, Maui, India, France, Aruba, Maryland, Tokyo, Bulgaria, Arizona, Los Angeles. Let's see here. Argentina, another New York, Memphis, Tennessee, Nigeria, Oregon, Bulgaria, Sao Paulo. Welcome, welcome, welcome. Awesome. I guess YouTube's got new emojis on the chat. It's the first time I've seen those. All right, so let's go ahead and jump into this. So welcome to the Trading Bot Masterclass. So I'm super excited to show you how to create a blockchain-based trading bot. A lot has happened in this space. There's always constant changes with this landscape, and I'm super excited to show you how this opportunity has changed and how we've updated this presentation to show you how to create a multi-chain blockchain-based trading bot powered by Flash Loans. So what we're going to cover tonight, just a quick overview in case you're, not 100% sure what you're getting yourself into tonight. I'm going to show you how to create this blockchain-based trading bot, all the concepts that you need to know. We're going to cover everything. We're not going to assume that you know everything and are an expert. We're going to start from a very basic level, and then we're going to quickly move into the advanced part, which is the coding implementation, okay? So a couple of house rules just to go over tonight. Keep everything in the YouTube chat, okay? So some people watching this might be members of the Blockchain Mastery Program. Some people might just join the one-time masterclass tonight. There's different places we can all communicate, but let's try to keep the chat for the session tonight inside the YouTube chat. But if you're not part of the Blockchain Mastery Program and you want to get all those extra benefits like, monthly videos, weekly updated videos on the hottest blockchain topics, access to all our master classes we do, then definitely reach out to Gregory@dappuniversity.com and we'll get you taken care of. So that being said, we will have some questions, extended time question and answer for this particular session tonight. Let's try to save the bulk of those towards the end. It's really crazy trying to watch, code and present and watch the chat, all at the same time and switch back and forth. So I will monitor that, every now and then, periodically, but let's try to save most of the questions till the end. While we will be doing some coding tonight in the presentation and setting this bot up, I wouldn't try to do everything step-by-step live while I'm doing it, okay? That can be a little overwhelming. There's going to be a replay link available to you no matter how you joined. So the best thing tonight is to get the big picture, get the lay of the land, and then probably, rewatch some of this to do some of the step-by-step instructions and also, your customizations. You can always reference back to this. And so the other thing I want to say is while there's unfortunately too much code in this presentation tonight to code out everything step by step. It's a pretty sophisticated bot here. If you want to get the step by step, instructions and level up your skills so that you can create advanced blockchain based trading bots, I want to open up an invitation to everybody who joined the class tonight. This is a very small thing that I've been doing that I haven't really been talking about on my YouTube channel. I've only sent some pretty limited invitations out to people who have, been a part of Dapp University before. But I do have a few slots open for my blockchain developer mentorship program. It's a 3-month remote coding boot camp with me, where we will teach you professional blockchain skills that you'll need to, do advanced trading bots or, break into the blockchain space. So I put a link down below for that program to apply. Again, it's something I'd only do on a very limited basis, but I wanted to open the invitation tonight. Everybody would join the class. And if you look around the chat, I believe we've got some mentorship students hanging out. So feel free to, jump in there and say, hey. All right. So last thing is just a quick disclaimer on this bot. I'm going to show you everything you need to know to create this bot. Put it out there and start creating your strategies. Of course, I can't make any promise of financial return from doing this bot. I have to just make the disclaimers for educational purposes only. And while I'm holding this class back by popular request, there just won't be any type of guarantees associated with that. But there's still a lot of good opportunity. So with that being said, let's go ahead and get started. I think we can get really excited. There's going to be a lot of great value in this class. So I'm going to pop over to my screen share. I'm going to kill my camera and we'll get into the dirty details. Let me just hit this real quick. All right, let's change over to my screen here. All right, so, okay. Let me move my other machine over. Sorry, I'm in my new setup, everybody. I have to kind of change how I do these classes a little bit. I've got cameras and computers and monitors floating around everywhere. I'm gonna get to a good spot where I can share my screen and, be on the same page. Okay, so let's go ahead and start off with some of the basics, all right? So let's kind of jump in first and foremost, like, what does this bot even do? We have to get the basics and talk about, what are your expectations? What does this bot do? What does it not do? So first of all, let's start with what does the bot not do, okay? So a lot of people, when they think of trading bots, they think about essentially their own little robot script that hooks into a cryptocurrency exchange and tries to predict like what the future cryptocurrency price is going to be. Like with Bitcoin, for example, like they hook their bot into, they get some API keys, they hook their bot that they've created into Binance or Bybit or whatever like that. And then they try to say, okay, I think the price of Bitcoin is going to go up $1,000. And so I'm going to buy it now and sell it when it does that, or use leverage or whatever. But that's not what this bot does. Okay. This bot's not trying to predict what future cryptocurrency prices are. It's a bot that takes advantage of opportunities now. So it doesn't do that because, those bots tend to blow up on you. Those bots can lose money. Like if you're wrong about the direction that the cryptocurrency price is going to go, the bot can just be, you can totally just blow up your account. So instead, this is a blockchain-based trading bot. So it doesn't try to predict what the future cryptocurrency price is going to be. It seizes opportunities that exist right now. It's blockchain-based, so it hooks into the blockchain directly. It can't lose you money. Okay. There's a small caveat there. You can, pay gas fees for unsuccessful trades that technically can lose money, but you're not going to like lose the cryptocurrency that you're trading with. And, the other beauty of this is you don't need any money to trade. Okay. Also with the caveat, you need some money to pay gas fees, but in terms of like buying and selling the cryptocurrency trading, you don't need it. You borrow it. And when you borrow the money, you can't lose any of it. So the features are, this is an arbitrage-based trading bot. It's looking for cryptocurrency price differences in the marketplace. It's blockchain-based, so it uses smart contracts with Solidity, and it uses flash loans. So you don't need any money to trade, like I was saying before, and there's no risk that you can lose the money that you're borrowing. So What we're going to cover tonight are the concepts for this. Again, we're going to get the bird's eye view of how does this work before you start coding. You need to understand the problem that you're solving and all the pieces that are involved before you start looking at the code. Because if you jump straight into the code without that context, you're going to be just scratching your head and not knowing what's going on. Again, we're not going to assume anybody's an expert. We'll start from the beginner topics, but if you have been down this road, we'll quickly get to the advanced concepts that you need to know in order to, get done what you need to. And then we'll move on to the implementation, like I was saying, which is the actual code. We'll set it up. We'll demonstrate how it works. And then we'll talk in depth on how you can customize this to create your own strategies. So the blockchain we're going to focus on tonight is Ethereum. That's what I focus on the most. It supports Solidity smart contracts. But the beauty of this is that this bot can be customized to work on multiple different blockchains. And we've updated this class tonight to do a different flash loan provider that out of the box supports different blockchains as well. So this bot will work on Ethereum, and then you can put it on other blockchains with minimal customization to support, like, Binance Smart Chain, which is also EVM compatible. So anywhere you can deploy Solidity smart contracts, and anywhere you can deploy apps and tokens that work like this, you'll be able to use this. There will be some customization involved, but it's much less than our previous iterations of this class. So I'm super excited. So one last thing to understand is, there's a certain philosophy of this class and how to teach this, okay? Because teaching trading bots is a tricky thing. I've done this class before where I essentially created a bot that was a strategy and made some transactions and showed the transactions working, and then just, gave away that code to everybody. Okay. And just okay, just hit go. It'll start making the trades with no customization. Now, the problem with that is as soon as I do that and give it to everybody watching in the class, they all start running the bot and they're all trying to do it at the exact same time. And essentially it's just either luck of the draw, whoever gets there first, or the most advanced people figure out how to tune their stuff and they start, winning. So problem is if I do that, then it's not necessarily going to work for everybody. So you got two strategies. You can do that, which that's the problem. But the other problem, and this is what I've chosen to do in this class, is to give you a bot that will work and give you a framework and show you how to customize it so you can start tweaking it pretty easily and implement your own strategies. Because there's two different options that you have. One is to become the best and the fastest at any given strategy, which you can do if you're a developer, but it's challenging. Or you can do something where you start looking for other opportunities. And that's exactly what we're going to that you'll be able to do that with the bot that I show you tonight, and also show you how to start creating those strategies as well to give you some more advanced knowledge. And yeah, totally awesome. So now I'm going to jump over to my screen share and show you the visuals for this. All right. Okay, so now I'm going to just do this and do screen share only. I think it'll be the easiest way. You don't have to see the side of my head. Okay. So let's jump into some more of the concepts, okay? Sorry, let me do that. Okay, so let's jump into the first concept you have to understand is what is arbitrage, okay? So arbitrage really is about just buying cryptocurrency on one exchange and selling it on a different exchange for a profit. Okay, basically looking at price discrepancies in the marketplace whenever they fall out of sync. So you have to understand, people ask me all the time, like, where does a cryptocurrency's price come from? Okay. And, a cryptocurrency's price isn't like coded into the blockchain somewhere, right? Basically, a cryptocurrency gets put out there and people decide what it's worth. Okay. And they express that by what they're willing to pay for it on a cryptocurrency exchange. And if you look at different exchanges like, Coinbase or Binance or whatever you like to use, you'll see that like there's always a slight difference in price of something like Bitcoin, for example. Like, let's say right now the current price of Bitcoin is like $31,000. Well, you might see that it's like $31,132 somewhere and $30,180 somewhere else. Right, so that's a small, price change, right? Like a $50 difference, if I remember what I actually said, right? So it's a small difference, right? And so the reason for that is because the different buyers and sellers on an exchange at any given point in time just have these slight differences. Like the exchanges are slightly out of sync. And, going further, cryptocurrency markets are incredibly volatile. The price goes up and down really fast, and it goes up and down really fast on different, it goes up and down really fast on different exchanges. Therefore, the exchanges fall out of sync. And so that creates an opportunity where you can do things like on this simple example on my screen here, where you can essentially, for example purposes, buy a token on exchange A for $100 and then turn around and sell it on exchange, B right here for $101. And that'll be a $1 profit. Okay. Now, that doesn't sound amazing, right? But what if you could do that with multiple units of the same cryptocurrency, right? What if you do it with 1,000 units? Well, that'd be $1,000 in profit. Okay. Or what if you could do this multiple times? Like, what if you could arb 100 units for $100 and do it 10 times? Well, that would be $1,000 profit. Okay. So you can do arbitrage on regular cryptocurrency exchanges like Binance and Coinbase, like I was saying before. But the problem with that is the price can move on you. So if you bought Bitcoin for $30,134 on Coinbase and sold it for, 31,000, 800, whatever I said, 1,000, the slight price difference, right? The problem with that, by the time you buy it on Coinbase and sell it on Binance, like the price could have moved on you by the time you transfer the funds over, and therefore it's not safe to do, right? There's going to be a lot of risk associated with it. But with blockchain-based trading, you have access to all the decentralized exchanges and in smart contracts in real time to ensure that the prices can never move on you when you're doing a trade. Okay. So that's the beauty of it. You have access to it in real time, all in one place. All right. That's why you can do arbitrage like this. You create smart contracts that hook into both of these, and the price will not move. Okay. Okay, so next, let's talk about flash loans, because this is the other really beautiful part of this equation. So what is a flash loan? Well, a flash loan is where you can borrow, millions of dollars of cryptocurrency for free with zero money down, as long as you pay it back in the same transaction. Now, that sounds crazy, what does that even mean? How on earth can you get a zero money down loan for free? Well, because of the blockchain, there's no way that you can steal the money or lose it or anything like that. They can just give you the loan because you have to pay it back instantly. The blockchain will enforce that. Okay. So what does that mean if you pay it back in the same transaction? Well, blockchain supports simple transactions and complex transactions. Okay. So a simple transaction would be like, if I just sent cryptocurrency from my account to yours, let's say I sent you 1 Ether. Well, that's a single step. It just says take Ether out of my account and put it into yours. That's just one step in the transaction. But you can do complex transactions that have multiple steps. Like step 1, borrow the money. Step 2, do something with it, like trade it on 2 exchanges. Step 3, pay it back. And step 4, keep the profit. Okay. And as a smart contract developer, that's what you're doing. You're coding smart contracts, and those smart contracts have functions. And inside those functions, you just code out each step line by line that does stuff like borrow the money, do something with it, pay it back, keep the profit. So that would look like take out a flash loan, trade the money, pay the flash loan back, and then pocket the difference. So arbitrage is a really common application of this. That's what we'll use today. It's so crazy because you can't lose the money when you're borrowing it because the transaction will revert. The blockchain will enforce it. So if you borrow like $1 million, you can't accidentally lose $1 million. That's really nice. Of course, there's always some caveats with this. Just because you can borrow $1 million doesn't mean you have to. You can borrow smaller amounts of money that you need for trading. When I say for free, sometimes there's usually a fee for these flash loan providers. Sometimes it's pretty small. Sometimes it's totally free. It just depends on which one you use. And again, there's zero money down for the loan, but anytime you do a transaction on the blockchain, you always have to pay a small fee to the blockchain itself. Okay. So there will be some cost whenever you attempt to trade. Those are just the small caveats there, but big picture, it's free. It's no collateral. Yeah, it's awesome. All right, so now let's look at another important thing to understand, which are, let's look at ERC20 tokens, okay? So the cool thing about Ethereum tokens is that Ethereum and other EVM compatible blockchains, they let you create your own cryptocurrency without creating a new blockchain. That's what's pretty cool. So you don't have to spin up a new blockchain with a native cryptocurrency. You can just create a smart contract and put it on the blockchain that represents a new cryptocurrency. Okay. So you might have heard of ERC20 tokens. All right. Well, that's what most cryptocurrencies that are tokens follow, this ERC20 token standard. It's just a standard that specifies like how smart contracts should work so that the tokens are compatible with wallets and exchanges, et cetera, et cetera. Okay. So that's the type of cryptocurrencies we're going to arb in this tutorial. Sometimes people ask me like, hey, could we arbitrage Bitcoin with this? You can't arbitrage Bitcoin natively. Okay. You could use something called wrapped Bitcoin, which is the ERC20 version of Bitcoin, like on Ethereum or Binance Smart Chain or Avalanche or whatever, right? You can't arb cross chain, like you can't swap Bitcoin for Ethereum or like a Solana token for an ETH token, for example. Okay. Earlier I said we could do this multi-chain. What I mean by that is that you could put this bot on different blockchains, but it won't be able to arbitrage, between different blockchains. You just be able to, change it to work on different blockchains, at any given point in time. Okay. So you're limited to a single blockchain at a time, but there's multiple blockchains you can do this on. And the tokens that you'll be arbing will be ERC20 tokens per this, ERC20 token standard that I got pulled up on my screen here. And really just a quick, quick explanation of the ERC20 token standard. Like I say, it's just a standard, but all it does is it like describes what functions the smart contracts are supposed to have, like name, symbol, decimals, total supply. It's got like a balance of function to see how many tokens you hold, a transfer function, which lets you move coins between wallets, transfer from, which kind of does the same thing, but only if you're not the owner, and like an approval, which means that the owner has to approve that tokens be transferred by somebody else before this transfer from function gets called. We'll see more of that as we get going. All right, so let's look at another topic that you have to understand, which is decentralized exchanges. So before I was talking about how we're going to be using decentralized exchanges for these arbitrage opportunities. We're going to be hooking our our trading bot directly into the exchange on the blockchain. So how do they work? Well, let's just look at one popular example of a decentralized exchange. Is Uniswap. And that's one of the exchanges we're going to use tonight. So Uniswap is a decentralized exchange. Okay. Basically, whenever you use it, you're looking at a website that's talking straight to the blockchain. Okay. So if you go to uniswap.org, go to the app, you basically connect your MetaMask wallet here. You select your blockchain and you tell it what token you have in your wallet. Let's say Ethereum. And then you want to trade it for a different token. Let's just say USDC. You just say, I've got Ether. I want to buy USDC. You tell it how much. You say, I've got 1 Ether. I want to trade it for USDC. And you connect your wallet, click swap, and it submits your transaction straight to the blockchain. There's no like back-end web server. There's no, you don't have to transfer money into Uniswap first. Like it just takes it straight out of your wallet and goes straight to the blockchain. Okay. So how does it work on the back end? Okay. So that website they were looking at talks directly to a smart contract on the blockchain. And it has these things called liquidity pools in the back end. So you might ask yourself like, hey, if I have Ether in my wallet and I'm going to get, 2,000 USDC for that, where does that USDC come from? Okay. Who is providing this cryptocurrency? Where does it live? Well, it lives in the app. Okay. It works kind of like a vending machine. You just tell it what cryptocurrency you have. It spits back out, a different cryptocurrency based on the exchange rate. But where does that cryptocurrency come from? Okay. Well, it comes in it lives in these things called liquidity pools. Okay. That are attached to the decentralized exchange. So liquidity pools are just like a reservoir of money, a reservoir of cryptocurrency that powers the application. So essentially you have these people on the back end called liquidity providers that are taking cryptocurrency from their wallet and they're providing it to the application so that it has money that other people can trade. All right. And they're doing this for the hope of financial gain from this activity. So they're parking their cryptocurrency here, basically trying to get some passive income. Okay. And the app gets money so that you can trade and you have liquidity for your swaps. Okay. So it's kind of a win-win-win. It's a win for the liquidity providers. It's a win for the app, and it's a win for you because you are now able to use the application. So these liquidity pools in most decentralized exchanges come in the form of trading pairs. So you'll typically see a pool that has 2 different tokens with it. So like you might see one that's USDC/WETH. That means that you put in equal weight of the USDC token and the wrapped Ether token or WETH together. So you supply 2 cryptocurrencies and it goes into one pool. And then anytime somebody trades USDC or WETH, it gets routed through this pool. Okay. Similarly, for another cryptocurrency, like if you have the Shiba Inu token or the Pepe coin or whatever it is, right? You supply that to the application along with a different cryptocurrency so that it can get liquidity and for each pool. So you'll see that pools kind of represent that they look kind of like order books on with trading pairs on a traditional order book exchange. So the cool thing about this decentralized exchange is that as a developer, you have access to all these smart contracts on the blockchain without using the website. Okay. So most normal people have to connect with MetaMask here and do swaps. But as a smart contract developer, you can plug directly into the Uniswap smart contracts and trade with code. Okay. It's pretty cool. All right. You don't even need MetaMask, right? As long as you got a wallet, as long as you got some Solidity code, you can create your own contracts that will do swaps for you. And that's sort of the fundamental, power that you have to create these blockchain-based trading bots. Because what you're going to do is you're going to create your own trading bots that hook into these liquidity pools, or hook into these contracts to plug into multiple exchanges at the same time to say like, okay, I'm going to buy on this exchange and sell on that exchange, all in the same transaction. And then you can also plug it into the flash loans, which I'll talk about here in a minute. And one other little point that I want to make here while we're talking about the topic of liquidity pools is that's typically where flash loans come from. Okay. So some people say like, okay, I'm going to take out this flash loan for millions of dollars, but where does that money come from? Well, typically flash loans are a secondary function of decentralized finance applications or DeFi. So basically like you typically don't have just like a flash loan app. You typically have a application that has a primary purpose, like a decentralized exchange or a savings and lending market where people can, deposit cryptocurrency to earn interest or borrow money. And those typically have their own liquidity pools where they just generate a secondary function, which is flash loans, where you can use that app and take out flash loans and then pay the money back. Sometimes they charge fees and generate revenue that way. Sometimes they don't. There's just different ways. So the whole point is flash loans typically come from these types of liquidity pools. All right. So that's an overview of some of the foundational concepts. Let's get more into the details of how the bot works. I'll take a quick peek at the YouTube chat, make sure everybody's okay. Okay. All right. So let's dig into the details of the bot. So let's look at the diagram of everything that's involved here. All right. You can kind of see this on my screen here. I've got different layers associated with this. Like here's everything that's on the blockchain. And then here's the stuff that's outside of the blockchain. So let's start off with the blockchain part. Okay. So again, we've got two different cryptocurrency exchanges, Exchange A and Exchange B. All right. Each of these has their own independent smart contracts with its own smart contract address. Let's just say that this Exchange A, for example, is Uniswap. All right. It's a DEX. It's got a contract. It's got, a token associated with it in the liquidity pools. So here's the token contract that we'll hook into. It's an ERC20 token, like I was saying. Let's say that this is the WETH token or wrapped ether token. I'll explain that more in a minute. So basically, here's Exchange A and here's Exchange B. This might be SushiSwap, for example. Okay, it's got its own independent smart contract and it's got the tokens on it as well. We can say this is the wrapped ether token as well. All right. Then you have the flash loan provider. Okay, I'll get into some of those more here in a minute. It could be DYDX, Aave, Uniswap, Balancer. And then it's got its own smart contract where you take out the flash loans. And then you have your smart contract that you create that's in the middle, that's sort of orchestrating the activities between all these other 5 contracts. Okay, each token, there'd really be 6 because there's really 3 tokens, or it was 2 tokens. Well, yeah, 5. Okay. So your contract will basically talk to Exchange A and say, hey, all right, I want to swap this token. It'll get the new token. Well, actually, first of all, it's going to take out the flash loan. All right. It's going to give the flash loan, but go back to your contract. Then your contract's going to call Exchange A and say, all right, take out that money that I just borrowed and swap the token. Okay, give me that token. I've got it back. And then it's going to talk to Exchange B to say, all right, I want to swap it for a different token. I'm going to sell it. It's going to talk to that token. And it's going to give it back to you. And then you're going to pay back the flash loan. And then you're going to send the profit to yourself. All right. That's all the stuff that's happening on the blockchain. And this is going to be sort of your master smart contract, your master trading contract that's written in Solidity. It has all the rules. It will not let you lose any of the money. All right. All this is on the blockchain. And that's the smart contract side of things. Now, your smart contract in and of itself doesn't know how to find arbitrage opportunities. All it does is it knows how to execute trades. It will not execute trades by itself, okay? That's where your bot comes into play, okay? So off of the blockchain, you're going to have a bot, which is really just an app or a process that runs on your computer, okay? It's a script or an app written in JavaScript that watches the blockchain, okay? It looks for any of these price discrepancies, and then whenever it finds one, it talks to your sort of master trading contract here that orchestrates this whole procedure to take out the flash loans, buy the cryptocurrency on this exchange, sell on that exchange, and pay it back and keep the profit, okay? So you have this blockchain side of things, and then you have the off the blockchain side of things, which is the bot that's watching the blockchain and then just tells your trading contract what to do. So let's dig into the specifics a little more of that. Your bot what it's going to do is it's going to look at each exchange. Okay. It's going to watch anytime a swap event happens. Okay. You're going to watch for specific token trading pairs. And anytime the exchange makes a trade with that trading pair, your bot's going to know about it. And it's going to check the price on both exchanges to see if there's a difference. And it's going to say, okay, can I profit off this trade? If so, it's going to call your trading contract and attempt the trade. Okay. And if it can't, it's to say, okay, no, I can't make a profit. So I'm just going to chill out and wait. That's basically what it is from high level. We'll see the complexity of that in the code, but that's the high level overview of what it does. So that's what your bot does. What does your trading contract do? Your contract takes up the flash loan step 1 of token 1. It buys token 2 on exchange A. Okay. And then it sells token 2 on exchange B. It repays the flash loan of token 1, and then it keeps the profit. All right. And the good news is it's got that fail safe. If it's not profitable, the transaction will revert. Why might it not be profitable? Maybe you have a bad calculation, or maybe someone beat you to the swap. Again, here's that caveat where if you attempt the trade and it's not successful, you can lose the money on the gas fees that you're doing that with, but you're not going to lose the money that you're trading with. And so here's sort of our diagram simplified with actual names. Again, we're going to use the Ethereum blockchain for this presentation. We're going to use Uniswap version 2 with the wrapped Ether token. We're going to use the loan. It's not actually going to be DYDX. It's going to be Balancer. I should change that to Balancer. And then we're going to use Sushi Swap, as the second exchange. We use a Shiba Inu token, and your bot's going to watch for this stuff. All right. Okay, so now let's talk about sort of the opportunity with this. All right. So again, before I was talking about how the best way to do this is just show you how to make a bot and then talk about how to customize the strategies. Okay. Because at the end of the day, there's so many variables in this equation that you can change. You can change the blockchain. You can change the tokens. You can change the exchanges. All right. You can even change the flash loan provider if you wanted to. And earlier in the chat, I saw somebody said, I might not give you a fish, but I'm gonna teach you how to fish. I think that's a pretty good analogy here. And so let me show you how you can do that. We'll get into this more in depth, but let's talk about from a high level, how would you create your own strategies? Well, first and foremost, the easiest thing to do is just change the tokens. Okay. So, Etherscan alone lists 1,275 tokens. There's way more tokens than that on the Ethereum blockchain. It's just like listing the 1,275 most popular and reputable tokens. There's, between that and the other blockchain, there's tens of thousands of tokens out there. Okay. They don't always have trading volume, but even if it was just 1,000, you don't have to be an expert in like discrete math to know that that's an insane number of combinations of how you could, combine different elements of a set that are 1,000 items big, right? It's an insane number of combinations, right? So you can change the tokens that you're watching. You can change the dexes, okay? Again, I was talking about Uniswap and Sushi Swap, but there's so many other dexes out there, okay? So if I look at a list like this, these are all the decentralized exchanges out there that have simply forked the Uniswap version 2 code alone. Okay. So there's 437 different Uniswap version 2 clones out there. All right. So you can change up the exchanges. Okay. We're using Uniswap version 2 very intentionally in our presentation tonight because there's so many different Uniswap version 2 exchanges that share the same interface. That you can easily just replace the address for, and it trades the exact same way. All right. So change the tokens, you change the exchanges, and then next, you change the blockchain. Okay. And if you look here on the chains on DeFi Llama, you can see all the different EVM compatible chains. that might have liquidity and tokens on it, right? Ethereum, obviously the largest one, but you've got stuff like Tron, you've got Binance Smart Chain, you got Arbitrum, which is an Ethereum layer 2, you got Polygon, which is an EVM compatible sidechain, Optimism, which is a layer 2, Avalanche, okay? So many different things that support Solidity. Like all these right here support Solidity, okay? So change the tokens, change the blockchains, change the exchanges. There's a nearly infinite number of combinations that you can tweak in order to customize your own strategies. So, you can also change flash loan providers, okay? There are some different flash loan providers out there. We've used DYDX a lot in the past. That's on Ethereum primarily. It's got some of the lowest fees. Aave is a flash loan provider. It's got a little bit higher of a fee. There's Dodo, which is on multiple blockchains like Vcred on Binance Smart Chain. The one that we're going to focus on tonight is Balancer, okay? I'll get into Balancer more here in a minute. But basically, Balancer is a pretty cool opportunity because it supports multi-chain out of the box. It's pretty easy to implement. You can do things like flash loan multiple different tokens at the same time. We're going to hook into that for our coding portion. Okay, so one more thing I want to explain. Two or three quick things I want to explain before we jump into the coding, okay? So one is how the ARB sequences work, okay? Because you have to understand how this works, okay? So, earlier I was talking about, oops, sorry. Let me just, let me pull this back up. Earlier, I was talking about these different parts of what your bot does, but let's talk about the actual ARB sequence in this visual. Okay. So again, this says DYDX, but let's change this to Balancer. Okay. So the sequence here is we're going to use the wrapped Ether token for our example tonight. You're going to take out a loan from Balancer, okay, for wrapped Ether. All right. You're going to take that wrapped Ether, you're going to swap it for a different cryptocurrency on the Uniswap. You're going to get back the Shiba Inu token. Once you get that back, then you're going to swap it on a different exchange, Sushi Swap, and then you can get back the ETH, pay back the loan, and then keep the profit for yourself. So that's the flow of the cryptocurrency. You're getting WETH, you're trading WETH for SHIB, you're trading SHIB for WETH, paying back the loan, and then sending the profit to yourself. That's the flow of funds for a basic ARB sequence. All right. All right. Now, let me talk to you how to recreate an arbitrage. Because, again, one of the best ways that I can demonstrate arbitrage live on the class tonight is to create a simulation environment. Okay. And that's also the best way for you to learn arbitrage is so that you can reproduce the circumstances that create an arbitrage opportunity. Okay. So that you can practice. All right. Because the last thing you want to do is, code out a smart contract and put it on the main net and then hope it works. You know what I mean? Just hope that the trades are actually successful, because that's not going to work. You're going to burn through so much money. You're going to pull your hair out. You're going to get frustrated. Okay. And the last thing I'm going to do in this class tonight is code out a solution and then sit here for a couple hours and just wait for an opportunity and hope that it pops up and that it's successful. Okay. So the same for you. You don't want to code up a strategy and finally get it working and be like, okay, now I have to wait an hour for an arbitrage opportunity to pop up and then boom. Okay, it worked or it didn't work. What you want to do is create an environment where you can actually force arbitrage opportunities to happen and prove that your code is going to work. Okay. So what we're going to do is create a simulation environment for that. All right. you kind of think about it like a flight simulator. You want to fly a flight simulator before you actually get in the cockpit of a real airplane. All right. The worst way to fly an airplane is just get in the driver's seat, hit the gas pedal, and take off. Like you're probably going to die. Right. Same thing here. So what we're going to do is basically run a blockchain node on our computer, a test blockchain. This says Ganache CLI, and it says Truffle. That's not right. This is Hard Hat node, and this is the Hard Hat project. So what we're going to do, we're going to run a development blockchain on our computer with Hard Hat, okay? And it's going to talk to the actual blockchain, okay? So what we're going to do is fork the actual blockchain. We're going to freeze it. We're going to get a copy of it on our computer that we can manipulate. Okay. So what that's going to do is we're going to have access to every single account on the blockchain without knowing the private key or the password or the seed phrase or anything like that, or the MetaMask account. We can pretend to be any account that we want to. We'll have access to every single smart contract on the blockchain, all the balances for these accounts, all the cryptocurrencies, all the tokens, all the exchanges, all the flash loans. We'll get all those on our computer, and we'll be able to manipulate it without paying any real money, without actually modifying the to make an arbitrage happen, so we can code the smart contracts so that when an arbitrage opportunity comes along, we know that our contracts are actually going to work before we deploy them to the mainnet. And this is exactly what you need to know how to do if you're going to create those strategies. So when you change up some stuff for your own strategy, you want to test this out, and it's the exact same environment that I'm showing you before you just deploy it to the mainnet and hope that it works. You want to prove that it works here and then move it should you choose to do that. Okay. So in order to make that happen, you need a Hard Hat node, which I'll show you how to set up in a minute. And then you're going to need access to a blockchain node with like Infura or Alchemy, quick node, something like that. All right. So if you set this up, how would you create an arbitrage opportunity? Well, remember before I was talking about how arbitrage opportunities happen when different blockchains fall out of sync. Okay. When basically, price discrepancies happen between exchanges. And so what we can do is we can freeze the blockchain, get access to all the exchanges, and then force a massive price discrepancy between two exchanges. So how would we do that? Well, we'll do it just like this. I'll show you a diagram. What we're going to do is we're going to freeze the blockchain, and we're going to unlock a massive whale wallet, okay, with the Shiba Inu token. Okay, it's a meme coin from 2021. And what we're going to do is we're going to get like 9 million or 9 billion, something like that, Shiba Inu tokens. And we're just going to sell them all on Sushi Swap. Okay. And what that's going to do is going to massively dump the price of that token on that particular exchange only. All right. That's how decentralized exchanges work. If you buy cryptocurrency, it raises the price for the next person. If you sell cryptocurrency, it lowers the price for the next person. Okay. And it raises the price or lowers the price in proportion to the amount of cryptocurrency that you buy or sell. So if I bought like 1 billion Shiba Inu tokens, it's going to jack the price up like crazy. Conversely, if I sell 1 bazillion Shiba Inu tokens, it's going to massively dump the price. Okay. And so that's what we're going to do. We're going to unlock a big old Shiba Inu wallet. We're going to get a whole bunch of Shiba Inu tokens. We're going to dump them on Sushi Swap, dump the price of Shiba Inu tokens. And then that means you'll be able to buy Shiba Inu tokens really cheap on Sushi Swap and then sell them on Uniswap for a profit. And we're going to purposely do a big exaggerated price discrepancy just so that you can see how easy it is to make an obvious arbitrage opportunity and jump on that. Okay. And so how do you calculate the prices whenever this happens? Well, you do it based on ratios. Okay. So these are liquidity pools like I was talking about. Basically, like you pair cryptocurrencies on the exchanges like Shiba Inu tokens and WETH tokens. You'll see like if there's 5,000 Shiba Inu tokens in one pool and 2,000 WETH tokens, that's 2 SHIB per WETH. That's what the price is. Okay. It's not expressed in USD necessarily. It's expressed in a ratio of these two exchanges. So are these two coins. On SushiSwap, if there's 1,000 SHIB and 1,000 WETH, that means 1 SHIB per WETH. So here you get 2 SHIB per WETH and 1 SHIB per WETH. And that means there's a price difference. Okay. You can buy, 2 more SHIB per WETH or 1 more SHIB per WETH on these different ones. That's where the price discrepancy is. Okay. And then one of the things you have to understand is people ask all the time, how much can you ARB? Well, the smallest reserve is going to be your limitation. So basically, if there's only like, 1,000 SHIB tokens here, then that's going to be, the maximum amount that you can ARB because there's 2,000 here or 5,000 here. Okay. And so I'll show you like real world examples of this. You can see like on, SushiSwap, like here's the actual Shiba Inu WETH pool. Okay, there's $1,611 of Shiba Inu tokens and then $1,614 of WETH tokens. It's not exactly the same, but it's pretty close. Same thing. Here's the Uniswap pool. Here's, $450,000 for the Shiba Inu, $450,000 for the WETH. It's equal USD valuations, roughly speaking, of each token, proportionate to one another. Okay, and here's the big whale wallet for the Shiba Inu that we're going to unlock. I'm pretty sure this is the burn address, but still, you can still unlock this account and get all these tokens and then, send them to your wallet so that you can dump the price. That's exactly what we're going to do. All right, the last thing I'm talking about is calculating profitability for your arbitrage. How do you know if an arbitrage is possible? Okay, sometimes you can buy cryptocurrency on one exchange and sell it on a different cryptocurrency exchange for a gross profit, but it is not necessarily a net profit. Okay, so what do you have to take into account? Well, if there's any flash loan fees, you have to deduct those from your profit, which the solution I'm going to show you tonight does not take any fees. So you have to worry about that. If they charge fees later, you will have to. But the other one is the gas fee paid to the blockchain. And that's what's going to kill a lot of ARBs is if it's a small arbitrage in particular, there might be a gas fee that prevents you from doing that. But thankfully, there's lots of other chains that have really low fees, layer 2s and such, that might make that a little bit easier. All right. So enough of the boring technical stuff. Let's jump into the actual coding. Okay. So you should see down below this video, wherever you're watching it from, whether it's the replay or the live presentation tonight, a link to the code, okay? And that code should be a zip file that you can download. You can open it, okay? On my screen here, I'm looking at the GitHub repository for this. You won't have access to the GitHub repository. It's going to be private, but all the code that I've got right here that I'll show will be the same as what you have in your zip file for the presentation tonight, okay? So go ahead and download that code, all right? And let's go ahead and open it in a terminal, okay? I got my terminal right here. And make sure you enter into this directory for the terminal. So thankfully, the only thing you need to make sure you have installed in your computer before you get started is Node.js, okay? You can see if you have Node already installed by going Node-V. All right, I've got version node 18.12.0. I recommend using the same node version as me just to eliminate any possible problems. A different version will probably work, but if you're totally uncertain, it's probably best you just stick with the same version as me. If you do not see anything pop up when you do node-v, or you know you don't have node installed, you can get this link right here to the Node.js website and just install it directly. Okay. All right. So once you've got node installed, or that you know you've got node installed, you're going to enter into your project directory and install all your project-based dependencies with NPM. NPM is just Node Package Manager. It comes bundled with Node.js. So if you have Node installed, it'll install NPM for you. So inside there, you're going to do NPM install. All right, I've already done this step, so it's going to, go really fast and will not have as verbose of an output as yours will if you install it for the first time. For you, it might take a few seconds, might take up to a minute. That's okay. But as long as you see a success message after doing that, you have your dependencies installed. Okay, so now let's go ahead and open the project in Sublime Text or whatever text editor you like. Okay, I use Sublime Text. You can use VS Code. You can use Atom. You can use, text edit as far as I care. Just make sure that you can edit files and the code all in one spot. Okay. So inside of here, you're going to see this thing called a .env.example file. So what you're going to do, you're going to copy this file. You're going to create a new file in the same directory called .env. All right. So .env is the full file name. So you might be used to seeing file names like, a JPEG file like profile picture.jpg or JPEG. So JPEG or JPG is the file extension in this case. Files don't actually have to have file names. They can be just dot files. That's what this is, the .env file. So you want to create a new file called .env right next to this one. And you want to copy the contents of the .env.example file and paste them into your .env file. Okay. So what is this file? Well, it's a place where you're going to put secret information that you do not want to put on GitHub. You do not want to put it on a different computer. You want to stay on this computer. Okay. It is where sensitive information like private keys go for your cryptocurrency wallet. That's why I'm not showing mine on screen. Okay. It's a place where you can put API keys and also just your project settings, which aren't necessarily sensitive, but they will change per environment that you use this application on. That's why it's called an environment variable. That's why it's called a .env file, is a place that you store environment variables. Okay. So copy that, paste all these contents into your .env file, and then we want to fill these things out one by one. All right. So the first thing we need to do is get an Alchemy API key. Well, what is that? Well, before I was talking about how we're going to connect our project to the blockchain, and then create this. Sorry, let's see here. Create this kind of like sandbox environment. This thing right here. So we're going to have our test blockchain. It's going to point to a blockchain node. So in order to connect to a blockchain, you have access to a node. You could theoretically run your own blockchain node yourself. It's a big pain in the butt. It's really expensive. It's hard to do. I don't recommend doing that. I recommend using somebody else's node. And that's exactly what Alchemy is going to let you do. Okay. So Alchemy is a Web 3.0 development platform. All right. And you can get access to multiple different blockchain nodes for free. So you can just sign up, create a free account. I'm not going to walk you through those steps. But what you're going to do as soon as you hit that dashboard is you're going to create a new app. You'll see the menu in there. You'll see apps. You click on apps, click on new. And whenever you do, you will see a page that looks like this. Let me just find it. I took a screenshot of it earlier and blanked out the sensitive information. it's going to show you your API key for your application. I'm pulling it up. Hold on a second. Okay, you'll see it looks like this. You'll see it says, you'll pull up your app, you'll look at the API key, you'll see like a URL, WebSockets, and then like the JavaScript implementation. What you want to do is find this API key itself, okay, and just copy that, and then put that back here in your .env file, where it says Alchemy API key. So like ABC123, okay. Obviously, that's not a real API key, but you want to put your API key inside the quotation marks, all right. So next thing, arb_for and arb_against. This is the Shiba Inu token and the wrapped Ether token that we're going to arb with. So you don't have to change these for the presentation tonight, but you will change these if you want to change the tokens that you're arbing, but you don't change these just to run the example that we're going to do right now. So private key will be the private key for your developer wallet. This is where the funds are going to go whenever you get the profits and also whenever you deploy your application to the blockchain. So you could theoretically, just for the presentation tonight, use the private key from Hardhat. Okay, I'll show you that here in a minute. Or you can use a MetaMask private key here. But if you do that, you need to make sure it's funded. All right. Price difference. This is just checking for the price difference between the two cryptocurrencies when you want to detect an arbitrage. Units, you can leave that at 0 for now. Gas limit and gas price will just be the gas limit for each transaction and the gas price that you're willing to pay. You can obviously change this based on whatever the current gas price on the blockchain is. Okay. So with that being said, let's go ahead and boot up the app. So the next step we're going to do is start our Hardhat blockchain. So before I was kind of showing you this diagram about how we have our have this here. So I'm looking at the chat. Some people are saying they're having a problem downloading the code. Is anybody else having a problem getting the code? So I'm able to download the code just fine on my end. If anybody's still having trouble downloading the code, just let me know. Okay, so I see a lot of people saying that it's working for them, no issues. Okay, awesome. So anyways, sorry, back to our presentation, everybody. So going back to this, we have our Alchemy link to get to the blockchain here. But now we want to start this thing up here, which is the Hardhat node. I know this says Ganache. We're not using Ganache. We're using Hardhat instead. So you can start it like this, NPX Hardhat node. And once you've done that, you've got your blockchain running. Okay. All right. And earlier before I was saying you could use your Hardhat private key in your .env file if you want to. You could get this first account in the list and then go back to your .env file. I'm going to use the example file, and you could put that private key, in here, for example, just to test it out for our simulation environment. If you're going to use an actual blockchain, do not use this private key. I repeat, do not use this private key if you're going to put real cryptocurrency in here. Okay. Because these are publicly available Hardhat accounts. Anybody who's watching this video or has used Hardhat will have access to this private key. And if you put real money in here, it will get stolen. Okay. So don't use that private key to store real money. I repeat. Okay. But you can do it for test purposes just to get the app up and running. All right. So one thing I want to mention is we started hard hat node here, but it's already pointing to the real blockchain. It's forked the blockchain. You're not actually going to make transactions in real blockchain, but we've frozen it. We've kind of got a copy of it on our computer that we can manipulate. And the reason we've done that is in this hard hat configuration file, this is the file that points your hard hat project to different environments. And here's the hard hat network. And we've added the forking URL. Okay. So you can see it's going to ethmainnet.galchemy.com/version2. And it's taking your Alchemy API key that we added from your .env file. Okay. And it is interpolating that. And now you're pointing your project to the mainnet and you're forking it already with this setting right here. So whenever you boot up your hard hat node, it's already frozen the mainnet. And now you've got copies of all the smart contracts, all the accounts, all the balances, all the tokens on this blockchain right here, simply because we added these few lines of code and added an Alchemy API key to our project. It's really powerful. It's a really nice setup. So I want to just explain to you why those few commands have made something really powerful for us. Now we essentially have this entire sandbox environment here, totally complete, where we can sort of, fly an airplane in a flight simulator before we try to, achieve liftoff on a runway and blow up and crash and die. So, now we're rocking and rolling. We're cooking with gas. Okay. So, we've got the private key to the .env file. We started hard hat node. Now we want to deploy the smart contract, okay, for the trading bot. All right, so we're going to explain how this code works pretty soon, but I want to just show you inside of here. Inside the contracts directory, here's the arbitrage contract, okay? It's your arbitrage contract here that does all of the trading stuff. That's the same contract that I was talking about. Let's see here. Here. So this contract right here is exactly what we're looking at here. Okay. So I'll explain this code, don't worry, but I'm going to go ahead and deploy it just to demonstrate the bot. That's what we're going to do. We're going to set the bot. We're going to get it running. We're going to demonstrate the arbitrage. We'll explain how it works and talk about how to customize it. So that's the next step. We're going to deploy the contract. So there's a command for it here inside the README. Again, you've got this exact same README here. It says README file. You can see all of the stuff on this GitHub page inside of here. So you can see the command, start your hard hat node, copy the deployment. All right, obviously don't do the backticks, but you can just copy everything inside the backticks. And then you can go to your terminal. What you're going to want to do is open up a new tab, okay? You can just do Command T if you're on a Mac, or you can do, wherever your terminal, you just shell new tab right here. Okay. You're going to keep your node running in one tab, and in a new tab, you're going to run this command from the README, npx hard hat run scripts deployed.js -- network localhost. That's going to put the arbitrage contract on your hard hat node, and you can see the transaction went through. Okay. You can see contract deployment, arbitrage. Here's the contract address. Here's the transaction hash. Here's the account it came from, which is the same account here in hard hat, 226. Okay. 226. All right. Here's a script that we use to do that. Deploy.js. Okay. Deploy contract, arbitrage. All right. And now we're going to run the bot. Okay. So I've got the blockchain running here. I've got my workbench right here. I'm going to open up a new terminal tab. All right. And I'm going to start the bot process itself. You just do node, which is a Node.js command to say, hey, run a certain script. And we have this bot.js file, which I'll show you in a second. And that's going to start the bot. You can see it's listening on port 5000. It's got the Uniswap pair address here. It's got the SushiSwap pair address. All right. And it's waiting for a swap event. All right. Okay. So what I'm going to do is take out this pane here, stick it over here. I'm going to take out this pane, stick it over here so you can watch these side by side. All right. So I've got my hard hat blockchain running. I've got my bot process running. All right. That's this thing right here. All right. We deployed our contracts on the blockchain. We've got all this other stuff because we already forked the blockchain. And we've got our bot right here. All right, that's what I just started. Bot, here's a blockchain, here's our workbench. And now the last thing I'm going to do is I am going to manipulate the price to force a price discrepancy, and then we're going to watch a swap happen. Okay, so I put the command in there. I'm not going to run it yet, but going back to this visual, let's just see here. Hold on. So this thing right here, we've unlocked a large Shiba Inu wallet. We're going to swap the tokens on SushiSwap to dump the price like crazy. It's going to force an arbitrage. And then our bot's going to detect that, okay? And it's going to call the contract, okay? Once we dump the price, let's just see here. Once we dump the price, our bot's going to detect it. It's going to call the contract. We're going to watch it happen in real time and watch it log up to the console. We'll observe the balances are changed. Okay. So I want to show you where that's happening. Inside the scripts directory, of course, we had a deployment script I showed you a second ago. We also have this manipulate script. Okay. And what it does is it basically takes that unlocked account, which I showed you on Etherscan. That's the SHIB wallet that we're going to impersonate. We're going to take like 45 bazillion. That's a real number. Just kidding. 45 bazillion or 40 bazillion SHIB tokens. And we're going to transfer this to our wallet. And we're going to dump the price on SushiSwap. High level, that's what this file does. Okay. And it does that with the hard hat impersonate account, which is pretty powerful. Okay. I'll go back to this in a second, but I just want to explain what's happening here. So now let's watch it happen. Okay. I'm going to run this command from GitHub right here. npx hard hat run scripts manipulate.js -- network localhost. That's the command. That I'm going to run it on this one. And then on the right, you're going to see the arbitrage happen. All right. I've run it. Let's watch it. All right. Boom. It worked. Okay. So on the left side, you can see the output of our script. So beginning swap, input token SHIB, output token WETH, swap complete. Price before, 1 WETH equals this many SHIB. Price after, 1 WETH equals this many SHIB. So you get way more SHIB for 1 WETH, which means the price of SHIB went down like crazy. Okay. That's what caused the big discrepancy. And our bot picked that up. Okay. It said waiting for swap event. A swap event was initiated on Uniswap. It's checking the price. Here's the current block number. Here's the tokens we're monitoring. Here's the price of SHIB WETH on Uniswap. It's this. And here's the price of SHIB WETH on SushiSwap. That's a massive difference. It's like 5 bazillion% different. Okay. So it determines the direction of the trade. Which exchange should you buy on first? SushiSwap or Uniswap. It says, okay, if we buy on Uniswap and sell on SushiSwap, what's the profit? Okay, well, the estimated profit would be this. Okay, So then it says, all right, I'm going to attempt, I've done my calculations. I'm ready to strike. All right, I'm striking. I'm attempting the arbitrage. And if the trade's successful, which in this case it was, it says trade complete. Okay, ETH balance after is this. Here's the amount of gas that was spent. ETH balance after is this. ETH gained loss, so 0.4. So that would have made about $800 in a single trade. Okay, if this were a real transaction. All right, so that's demonstrating the bot actually working. All right, so now let's kind of jump into the dirty details and explain the code behind this bad boy. Yeah, it's definitely a lot of SHIB. Okay, so let's get into the details of the code. All right, so let's start off with Balancer, or sorry, with this contracts. Start with the arbitrage contract itself. Okay, so what we do at the top of this, first of all, here's our contract. We only have one contract inside of here. It's nice and clean. If you see any of our previous master classes, it's a lot cleaner. There's not a bunch of contracts just floating around everywhere. We're importing everything we need from different libraries here. We have this contract. It's called arbitrage, okay? And it inherits from this I flash loan recipient. Well, what the heck is that? Why do we need it? Where does it come from? Well, we are using the Balancer protocol for flash loans, like I mentioned before. Okay. So again, what is Balancer? Balancer is a DeFi liquidity protocol. Basically, it just provides liquidity to other DeFi applications. They can hook into it to bootstrap their liquidity or to get more liquidity. They have a DEX built on top of Balancer as well. Okay. But the benefit is Balancer has flash loans. All right. And Balancer, the nice thing about Balancer flash loans is that they are zero fee at the time of doing this presentation. You don't have to pay anything to use them. They are multi-chain in the sense that they're deployed to multiple different blockchains. You can use them on Ethereum. You can see all the different blockchains that it supports out of the box here. Okay. And you can see the deployment addresses here: Arbitrum, Avalanche, Optimism, Polygon, Spolia, ZVK, EVM. All right. And it's pretty easy to set your app up with Balancer flash loans. Here's the demo. Basically, what you're going to do is you're just going to import the Balancer libraries, just like the documentation says. We've got this documentation linked in the README. Okay. You install the node modules that have these contracts in it, the interface for the I vault for Balancer and the flash loan recipient. You create a contract that inherits from this I flash loan recipient. That's what we're doing right here. So arbitrage, that's our contract name, is I flash loan recipient, just like the documentation. If you look at these back and forth, they basically look the same. We just also implement the Uniswap router, which we'll use in a minute. I'll show you that in a second. But then basically, we inherit from that. We get the address for the Balancer vault. Okay, that's basically just where the flash loans are coming from. All right. We store that here, just like the documentation says. We're not doing anything fancy. We're just doing exactly what the documentation tells us to do. Okay. And then high level, we just need two functions inside of our smart contract. One that takes out the flash loan. That's this, make flash loan. All right. And then a callback function that the Balancer smart contract is going to call on our smart contract once we receive the money. Okay. So basically, we have to put a function in our contract called make flash loan that talk to Balancer. It's going to take this vault right here and call flash loan and pass in some information. And the Balancer smart contract is going to call back to our contract. So we must have this receive flash loan function. And this is where we'll like do the trading right here. So we just set it up to say, hey, here's what I want to borrow and ask for the money. It's going to call back to us here. And then like sort of where these ... is instead of our contract, that's where we're going to do trades. Okay. So I'll go back up and read some of this code, but basically you can just see we have an execute trade function that calls vault flash loan. We don't call ours make flash loan. That's okay. You can name this whatever you want to, but you do have to have a receive flash loan function. That's what Balancer is going to be looking for when it's calling back to you. So we do execute trade, which does some preliminary work, but it calls this vault.flash loan, which is exactly what the documentation does here. Okay. And then we have this receive flash loan function, which is the exact same function name as the documentation, where we get the money. And then inside of that, that's where we do the trades, which I'll explain that more here in a second. But I want to just point out the similarity of we're just following the instructions from what Balancer tells us to do and implementing that in our smart contract. So from a high level, anytime our bot calls the contract, it's just going to call this function or this function right here. No, sorry, this function right here. And then everything else is going to take care of itself. This is the main entry point for trading. Is just boom, execute trade, and then all the other magic happens on the back end. Okay. So let's do a little bit more of a review line by line of what's going on here. So basically, we import the Uniswap version 2 interface. It's important to note that Uniswap and SushiSwap both use the same code base, more or less. They use the same interface is what I mean to say. So they basically work the same way. Lots of other Uniswap applications work the same way. That's why we focus on that. It's really easy to set up. All right. So we had to import the Uniswap version 2 interface here. So we save the Uniswap router here as URouter. That's what URouter stands for. And then SRouter stands for SushiSwap router. We use the same Uniswap version 2 router interface, like I was saying before, for each one of those, for SushiSwap and Uniswap, because they both share the same interface. We have the state variable to save the owner. That's your trading address. So the private key that you stored in your .env file, the address for that key is what's going to get stored here in the owner address. That's the only person that can like call the functions on this. You can see like execute trade, stuff like that, you know, like, yeah, all that type of stuff. Okay. All right. So inside the constructor function, this is the function that's run once and only once when we deploy the contract to the blockchain. It just takes some variables like the Uniswap router and the SushiSwap router, or sorry, Uniswap and SushiSwap. It saves those to these state variables up here. It also saves the owner address to the person who deployed the contract. Okay, so in terms of trading, all right, here's the execute trade function. So what's it going to do? Well, we have a couple arguments. One is like, do the, which direction do you want to start on? Do you want to start on Uniswap or start on SushiSwap? Okay. Well, that's what your bot's going to decide, but it's going to have a Boolean value on does it want to start on Uniswap or not. Okay. Token 0 is the token that is going to be the first token in the ARB sequence. Token number 2 is going to be the second token in the ARB sequence. These are going to be addresses. Okay. Your bot can change these. That's why we kind of want that's why we kind of want the smart contract to be agnostic. We want the bot to sort of decide what to do. Then the flash loan amount is the amount of money that you're going to be borrowing to pass into this. Okay. And then basically what we're going to do is these lines right here, all they're doing is setting up the variables that we want to send to the flash loan to ask for it. Okay. So if you look at this right here, this vault flash loan, it requires some arguments. One is the address of the smart contract, the tokens that you're arbitraging, the amounts you want to borrow, and then the user data that's going to get passed in later. That's all we're doing is we're setting that up here. We're basically taking these we're taking these function arguments, we're packing them into this data object here. we're creating the tokens variable for the tokens that we want to borrow. In this case, it's just one token. It's just an array of one token. The flash loan amount, which we have an array of amounts for each token. We just do the flash amount that we requested here. And we pass all that into the flash loan provider to ask for the flash loan. So really, beginning the trade, we set up the information for the trade, and we ask the flash loan provider for this trade. Sorry, for the flash loan. Okay. Now, once Balancer receives our request, it's going to fulfill the request here on this function. It's going to call back to our smart contract with receive flash loan. Okay. And so what it's going to do is it's going to pass in the tokens that we passed in here. It's going to pass in the amounts that we passed in here. It's going to pass in any fee amounts. Okay. It's going to pass in any user data that we passed in here, which in this case was just starting Uniswap token 0 and token 1. We make sure that only the vault is calling this. Okay. And then we essentially unpack our information here. We get the flash loan amount. We unpack our variables that we passed in the first time, like starting Uniswap, token 0, token 1, and the user data. All right. And then here is where we start doing stuff with the money. So basically, we set up the path for which direction we're going to go. All right. And so we sort of have a fork in the road. You have this conditional logic here, if else. So remember how I talked about if we do it start on SushiSwap or not, or start on Uniswap? If we're starting on Uniswap, we're going to basically swap the tokens first on Uniswap and then swap on SushiSwap. If we're not, we're going to do the opposite. Okay. And that's what I was saying before with this. If you track the token flows, basically, if you start on Uniswap, you've borrowed the money. You start on Uniswap, you get tokens back, and then you swap on SushiSwap and get the tokens back. If you're not starting on Uniswap, you're swapping on SushiSwap, getting tokens back, and then swapping on Uniswap. So the order matters. Okay, so if you're starting on Uniswap, it's just a swap on Uniswap first. You reverse the order of the tokens right here, and then you swap on SushiSwap. Okay, if you're not starting on Uniswap, then you're swapping on SushiSwap first, okay? And then you're reversing the order and then swapping on Uniswap. Okay. And then whenever that's done, you're going to transfer the flash loan amount back to the flash loan provider. That's how you pay the money back. And then you transfer the profit, which is just the remaining balance of token 0, the token you borrowed, back to your address. Because the whole purpose of arbitrage is that you have more tokens than when you started with. Okay. So if you start off with 0 tokens, you flash on 1 million tokens, and then you get back 1,001,000 tokens, then you pay back the 1 million tokens. You have 1,000 tokens left over, and you just pay those back to yourself. Okay. You transfer straight to the owner's wallet, which is what you set up here. Okay. And then finally, this swap on Uniswap and swap on SushiSwap functions are also in the smart contract. Basically, we just have abstracted these as internal functions down here. They both do the same thing. It's just that they use different routers. So Uniswap has something in the documentation. You can see it here. It has a function called swap exact tokens for tokens. It just takes the amount in, the amount out, any call data for the path, the address to, and a deadline. And we do that for Uniswap and SushiSwap. Here's the swap exact tokens for tokens function. We pass in the appropriate variables here. Okay. And we wrap that in a swap on Uniswap function. And then for SushiSwap, it's the exact same thing. It's just that we're using the SushiSwap router. So we're using the Uniswap router here to call the swap exact tokens for tokens. And then we're using the SushiSwap router to call swap exact tokens for tokens on SushiSwap, because Uniswap uses the exact same interface as SushiSwap, therefore uses this exact same function. All those apps that fork Uniswap, like I was talking about before, on this Forks tab, all these apps, all right, Pancake Swap, Sushi Swap, Buy Swap, Katana, all these dexes, because they've forked Uniswap, are going to have this exact same function on them. That's why it's really nice to be able to know this stuff so that you can just boom, just swap on those exchanges. All right. Okay, so that's an overview of the smart contract code. Now, let's look at the bot code. All right, so the bot is going to be a little bit different. Okay, so the bot is all in JavaScript. All right, the smart contract all in Solidity. This is a Node.js script that just runs in the background here. Okay, and essentially what this does is it pulls in all your environment variables here. Okay, it pulls in your libraries at the top, like your .env. It's got some helpers and a config.json file, and you can see all these other helpers here. We've got a helpers directory. All right. It's got all these functions inside of it. I probably won't go through all these functions step by step, but I'll go through the main parts of the bot that are important to know. Let's just keep helpers open. And let's also pull this index.js file. Or bot.js file, sorry. Okay. So yeah, we've just got these external functions from our helpers, our libraries, all pulled at the top. We pull in all our .env, our environment variables from our .env file. We just set up some variables at the top, but then the bot really runs off this main function. Okay. So this main function is where it's doing everything. Okay. So inside this main function, what we do is we just pull in the smart contracts first. Okay. We get the token 0 contract, like WETH tokens, token 1 contract, like Shiba Inu tokens, token 0, token 1, and the addresses. Okay. And then we get the Uniswap pair and the SushiSwap pair. Okay. And then we log the pair addresses. So when you see that in the terminal here, you can see that's logged when you start the app here. Start the bot up here. Here's the Uniswap pair address. Here's the SushiSwap pair address. You can pop those in Etherscan and see them for yourself. Okay, so now what we do is we monitor each trading pair. That's how your bot works. It looks for trading pairs. Okay, like Shiba Inu and WETH token on Uniswap and Shiba Inu and WETH pair on SushiSwap. You monitor a single pair on 2 different exchanges. So you can see the Uniswap pair here on line 29 and the SushiSwap pair on line 58. Okay. I've collapsed these just so that you can see a high level of what's happening here. So this main function. What we do is we listen for every single swap event that occurs on the blockchain for these pairs. Okay. So basically, blockchains in smart contracts have things called events. So whenever you do something on the blockchain, you can create an event that gets emitted and people outside the blockchain can listen for those events and act upon them. So that's what we're doing here. Anytime a swap happens, a swap event is triggered, and we're saying you pair on swap event, run the bot and see if any price discrepancy happened. So similarly, if a trade happens on SushiSwap, we're going to listen for the swap event and see if anything happened. Okay. So I'll take you through step by step what it does. Basically, it looks to see if it's already executing. So if it's already executing, it's not going to do anything. But if it's not, it's going to check for a price difference. So it checks price on Uniswap. Okay, we've got a helper that does that. Okay. A function down here on line 90. Basically what it does is it takes the exchange, token 0, token 1, and it looks for the price. So it does this calculate price function. That's in the helpers. Basically what it does is it gets the reserves, which just tells you how much cryptocurrency is in the liquidity pool, and it divides them, okay? Remember I was talking about how essentially you get the prices by just dividing the amount of cryptocurrency in each pool. That's what this is. So there's 5,000 Shiba Inu tokens and 2,000 WETH. It's 2 SHIB per WETH. If it's 1,000 SHIB per 1,000 WETH, it's 1 SHIB per WETH. That's what calculate price does. It just gets the reserves, which just tells you it's just an array that's like, okay, you got 5,000 SHIB, 2,000 WETH. And you do the math here. You divide X by Y to get the price. Okay, that's what calculate price does. So that's the price on Uniswap. And they do the same thing for calculate price on SushiSwap. Okay. And so we can just convert those to fixed units. All right. And we calculate the price difference. All right. And then basically we say, here's what the price difference is based upon this calculation. And when we did our swap, you can see that logged up at the console here. Okay. It shows you the price. Here's the price on Uniswap. Here's the price on SushiSwap. And then here's the difference expressed as a percentage, which here's the difference in percentage that we calculated into with console logging statements here. All right. Okay. So it checks the price and then it determines the trade direction. Okay. So this function here determine direction. What it does, it says if the price difference that you pass in that we just calculated is greater than or equal to the difference here, okay, then it's going to say, hey, you want to do your arbitrage starting on Uniswap and selling on SushiSwap, and it will return the addresses in the right order. So it means start on this smart contract address and then do this smart contract address second. Now, if it's the opposite, if the difference is the other way, then you're going to reverse the order. Basically, you're going to buy on SushiSwap and sell on Uniswap, and it will return the smart contract addresses as an array in the correct order. So you can see that here. Determine direction, potential arbitrage direction, buy on Uniswap, sell on SushiSwap. Okay. All right. And then, so that's the price difference. That's the router path. So basically, it's going to return the two addresses in the right order, okay, to pass into your trading contract, okay? Because you want to know, do you start on Uniswap or not, okay? That's what we're figuring out right there. So then, if it doesn't give you a router path, it's going to say, hey, we couldn't find a profitable arbitrage, and the function is just going to stop running. Okay, so if there's no router path, it's going to say, hey, sorry, no arbitrage is currently available. We're not going to execute. We're going to end this whole function. But if it does have one, we're then going to calculate the profitability. So we're going to determine profitability, and we pass in the information, the router path, token contract, token 0, token 1. And you can customize this, which you see the notes here. But what we do is we get the reserves, just like we saw in the calculate price. We get the exchange we want to buy on, get the exchange we want to sell on. And then we log all that to the console. You can see that here. We show the reserves here, SHIB, WETH. And then we calculate whether it's going to be profitable or not. So we do this function on Uniswap, get amounts in. We saw that in the Uniswap documentation earlier, okay? Just next to the swap exact tokens for tokens. Okay, you can see that in the Uniswap documentation. Okay, you can see that. And then you can do get amounts out, which will say, okay, if I give it this much cryptocurrency, how much cryptocurrency is it going to spit out? You can see also get amounts out. Okay. All right. And then basically we look at the amounts in versus amounts out. We simulate it. And we just calculate the amount of price difference it's going to be. And then we also factor in the gas cost. We estimate the gas cost by the gas limit and the gas price that are set in your .env files. And then we simulate it, okay, by doing the math here, okay. We basically took the balance of, we calculate the amount difference minus WETH balance, and then get the amount difference. We log out the console, and we show you whether it was profitable or not. So basically, if the amount that you get out is less than the amount that you put in, it's not profitable. But if it is, we return true, and we log all the information to the console. And you can see the summary of that about what you will expect to gain in profit from the arbitrage before you attempt it, okay? And so if that thing returns true, then what we do is we save it to a variable. Is profitable, true or false? If it's not profitable, it's of course going to stop. That's what this code block here does. But if it is profitable, then we execute trade. All right. And then that's where we do this function down here, execute trade. This is where we finally call to our smart contract. Okay. Our bot's been watching all the opportunities in the marketplace. All right, it's been doing the calculations. If it finally finds one that's profitable, it's going to go ahead and call to our contract right here. Okay, and so that's what this does. Basically, if we start on Uniswap, we set up that variable as true or false. We create a signer, which is just an Ether's wallet with the private key. It reads the private key from our .env. We get the token balance before, okay? We get the ETH balance before, so we can log these to the console. And then we call this execute trade function. We connect our arbitrage contract to our account. We build a transaction with these same variables, okay? We're saying start on Uniswap, token 0, token 1, flash amount. All right, token 0. Sorry, start on Uniswap, token 0, token 1, flash amount. And then we put in the gas limit for the function call. And then we just wait for the transaction to finish. All right. And whenever it's done, we say trade's complete. And then we put a summary of everything in the terminal right there. And you'll actually check the balances after it's finished. We'll read those from the blockchain to see if it worked properly. And we put a summary here on the page, which you can see here's what it expected and here's what it actually got. So you can see, the math's not perfect, but it's pretty close, okay? It expected the total WETH gained lost to be 0.36, ended up being 0.39, okay? So it's a little bit different. It's not a perfect calculation, but it's pretty dang close, okay? And so here's the expected amount, and here's the actual amount that happened that we fetched in the blockchain after it's actually done. And so that is, that's how we do it for Uniswap pairs. And it's the exact same thing for SushiSwap pairs. It's just in the opposite order, okay? So I'm not going to explain all those things step by step because it's pretty much the same thing. It's just in the opposite order, all right? But that's all the functions in there and how it works. All right, so the last thing I want to show you here is how do you put this bot on the mainnet, okay? Or if you choose to do that, or to a real blockchain. Well, you need to change your config.json here. So first of all, if you deploy it, you need to update your arbitrage address here, but you want to change some project settings. So if your contract is put on the blockchain, you want to change this to is deployed true. And if want your bot to start looking at the actual blockchain, you want to set is local to false, okay? So that means you're going to start looking for actual arbitrage opportunities on the mainnet, not your test blockchain. So what I'm going to do now is set this to false and set this to false, which means that, okay, I don't actually have my smart contract on the mainnet, but I am going to point my searcher bot to look on the mainnet. But whenever it finds something, it's not going to call my contract. We actually have a safeguard for that inside of here, which is project settings is deployed. If it's not deployed, it's not going to call the arbitrage. So you can basically like set your searcher bot into watch only mode, which is pretty cool. So you can kind of play with it. And that's what I'll do right now is I'll just sort of run that. Oh, that's not the right one. So node. Yeah, now I'll kind of just like put the bot in listen only mode. And while we're doing our Q&A here, I'll go ahead and just, kind of see if it detects anything. All right, so that's pretty much it. That's an overview of the bot, how to set it up, how to tweak it with your own variables, an overview of the smart contract code, overview of the bot code. And so now I want to go ahead and open up the floor for some Q&A here. If you got any questions, go ahead and drop them in the thing here in the YouTube chat. So John's saying, didn't know about the Slack info. So you would have gotten the Slack channel if you sign up for the Blockchain Mastery program for the presentation tonight. So thank you, Packer Man. I hope I'm saying that right. You said a great presentation tonight. Thank you. Yeah, awesome. So what kind of percentage gains can you get with this? So, I mean, it's not really a percentage gains, right? Like, because it's like an infinite percentage in gains because you're not actually trading with, any real money, right? Like, I mean, you don't have to have money to trade. But I think I know what you mean, like percentage based on the principle that you're arbing. It's going to be a pretty small percent, but the total amount can be big, if that makes sense. All right, so it just it's trying to actually execute a trade. Let me make sure I kill that. So the config is on the screen here. So up to last step in deployment for mainnet, basically you want to just change your .env file to put your actual private key. And then you want to basically run the script, the deployment script against the mainnet. So that would be like, you do this, you do mainnet, right? But you'd have to go into your hardhat.config and actually add the mainnet. You'd have to copy this, do mainnet, do ETH mainnet, and then not fork it. Let's see here. When it says listing on 5,000, is it 5,000 different pairs? No, that's the port. That's the web server port. Port 5,000. Is it going to look for all the token pairs listed on Uniswap and SushiSwap? No, it's not. It's only going to look for the pairs that you tell it to. How would you deploy a BSC on mainnet? It's the same thing I was talking about. Basically, you'd have to change the BSC network here, and you have to change your settings in order to do that. I'm using Node version 18. I'll show you. 18.12.0. Yes, you can look for the gas price in real time. So you can do it with estimate price. So you can do like get gas price or estimate gas. I'll put a link to this in the YouTube chat. Someone's asking about it. So can I explain the config changes? Yeah. So basically, this is local is false. This is whether or not your bot is watching for opportunities on the main net or your local machine. So if you're using the forked blockchain locally, this will be true. If you're pointing to the main net, this will be false. So is deployed is about your smart contract. If your smart contract is on your computer, this is false. If it's on the main net, it's true. Yeah, if you don't have the Slack link, yeah, just mail back in. We'll get it. Can I quickly explain the config? I just did that. Okay, so Dirk's asking, since the first dumping the price, do the others do regular trades also see the price changes, or are they only instantaneous for us? Well, it's going to populate on the entire blockchain. I mean, nobody else is going to see it on your development blockchain, but if the price was dumped on the actual blockchain or you manipulated it somehow, then yeah, everybody's going to pick that up. How do we add the new pair? Yeah, you add the new pair basically by just doing it in your .env. So basically, here's the arb4, arb against. You would just swap these out for different token addresses. Could you do arbitrage only using JavaScript without deploying a Solidity smart contract? The problem with that is you can't do flash loans properly, right? It would be just like buying and selling on Coinbase and Binance. You can't like enforce it on the blockchain. That's a good question, Dirk. So I do know Dirk because Dirk's been inside the blockchain mentorship. He's one of our current students in there. And yeah, I did put, just to also the quick thing again, some people are saying like, oh, the code's kind of going over my head. Totally get that. If you want to get the coding skills in order to make this type of thing work, one of the best ways you can do that is to have hands-on mentorship. I did put a link down in a link below this video tonight that shows you like I've got some spots potentially open for this pretty soon. If you want to apply, I did put a link down there. I'll just leave this up on the screen here to submit the application for that. Okay, so is the bot going to look for all the token pairs? No, it's not. That's what I was saying before. Could the code be deployed in the cloud? Yes, you can put your searcher bot in the cloud. Is there a way to estimate the gas price for calling the contract? Yes, that's what I was talking about. It does do that. It does do that in the code. Okay. So that's what the bot.js does here and calculate profitability. So it does the gas price calculation right here, gas limit, gas price, estimated gas cost, and it deducts that from the profitability. Now you can get more granular and you can estimate the gas in real time. Right now, inside your .env, it's just using a gas limit and gas price setting. If it's in a simulated environment, what do you need to make it live? Yeah, you deploy it to the mainnet like I was talking about a minute ago. Deploy to Polygon. Step one, create a wallet on mainnet, add some ETH, private key to config and deploy. Yep, pretty much. if you deploy to Polygon, can you share the changes that you can make? It's the same thing as deploying to the mainnet. You just have to change all the settings. So to find an opportunity, is there a consideration on LP size? Really just the smallest reserve is the limitation. That's it. As long as there's a profitable opportunity on a small reserve, again, you can do like an arbitrage that only makes you like $100 in profit, right? But what if you did it over and over again? Okay, I answered the mainnet question. When I run hard hat, it asks me to create a new JavaScript project instead of deploying accounts. You're probably just running the hard hat command by itself. How to get the smart contract to the mainnet? I think I answered that question already. So bots is waiting for swaps. Didn't work for you. It's probably because it hasn't detected one yet. Just decentralized exchanges, no centralized exchanges. Arbitrage wait for deployment is not a function. That's because you're probably using the wrong version of hard hat. You need to make sure that you use npx hard hat that we have in the package.json. Make sure you do npm install and you do npx hard hat. I would add just a new contract for adding a third token. Or you can use the same contract and just have the bot running multiple processes. So same thing, Polygon, same thing as mainnet. You just update the variables. Do you have your bot always running on your computer? Or do you have it hosted? So, I mean, honestly, the best thing to do is going to be host it in the cloud, but you can have it running on your computer. Let's see here. So I have summaries of running the bot for a whole day week. So I don't have the transactions. So part of it is I can't show the transaction. Like I can't show just a blockchain wallet address that's got all the history because obviously that's going to reveal bot location. One of the last times I did do this class, though, one of the students that I was working with did make $1,000 in their first weekend in profit with very minimal customization. Was arbitrage, the test arbitrage.js touched in the presentation? No, we didn't really cover it that much in the presentation. It's a good question, though. It is test everything. Unfortunately, I don't have a ton of time to go through it, but basically it's just doing some really basic stuff. It's just testing that it sets this stuff. The real testing is in the scripts. Do the scripts work? So someone's asking about the mentorship. Is it different than bootcamp? Yeah, it's totally different. It's totally hands-on, 3-month, fully immersive remote coding bootcamp. I'm inside of it. Does it search for random token pairs with arbitrage? Oh, yeah, only the specific tokens. Why wouldn't you use provider, get gas price? You can do that as well. Yep, you can do it all in the same block. That's a good question. So like swap on Uniswap versus swap on SushiSwap, could you use a library that doesn't use those names? Yeah, you could abstract the code to have a function that just takes parameters. You definitely could do that. Let's see here. What's the software needed to run this code on mainnet? It's the same software. How to find an arbitrage pair? Well, that's just where a little bit of research comes into play. You got to try a bunch of different pairs. How do we watch this video? You'll have access to this link. I'll email it out later. If you're in the mastery program, you can jump into mastery. Let's see here. How many exchanges can the new exchanges? You're just going to change the router addresses. Okay. So basically, that's in the config.json file. Here's the different exchange addresses. So if you want to do a new exchange, you got to look up the addresses and replace these here. Okay. Can we trade NFTs on DEXs? You can, but it's going to be more marketplaces, and that's going to be a lot more complicated. So can we essentially manipulate prices? Are there any SEC considerations? So, in the script that we did tonight, I was manipulating prices on my sandbox environment. You know what I mean? I wasn't actually manipulating the prices on the mainnet. There's nothing really about this bot that's actually exploitative in any way. It really is just looking for natural opportunities to come from the marketplace. It's not like a predatory bot. It just looks for price discrepancies. Like I forced a price discrepancy on my computer by itself, but I would never, do that on an actual blockchain. It doesn't, like you wouldn't even be like, that wouldn't even be profitable for you if you did it. Can you make 4 exchanges? Yep, you can definitely do that. What would be a good opportunity to use AI to find opportunities for arbitrage? Yeah, now you're asking the right questions. Would it be appropriate to use Flash bots as arbitrage app? Yes, you can definitely use a private block producer to bypass the mempool if you wish. Is there a way to ask questions after the masterclass? Yeah, the best way is to jump into the blockchain mastery Slack program. Can we do changes on the strategy after deploying? You can change the bot code, but you can't change the smart contract code. Can we use this code as is without making changes on mainnet and it work to possibly profit? You're probably not going to work with the exact same token pairs that I'm showing because lots of other people can try to do that too. But again, I obviously am not going to guarantee any profit, but you could make profit by just changing the tokens. Again, I'm not going to guarantee that, but yes, it is possible. What kind of wallets can be used? Ethereum wallets. Yeah, I don't see you use any wallet. Do we have to use any wallets? You don't have to use a wallet, but you want to be able to access the funds that you receive from MetaMask. How to add DEX contracts, then V2 forks. So basically, okay, so you're going to have to basically, change this part of it, okay? So you're going to have to change the interfaces besides Uniswap version 2. So you'll import the interfaces for those. And all this stuff where it's like swap on Uniswap, swap on SushiSwap. This is where you have to look at their documentation, just like I looked at the balancer stuff before, and then change it out there. To use multiple tokens through balancer, can show the example. So I can't show the entire example, but basically the whole idea is, sorry, let me blah, 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 blah. Basically the idea is if you want to do multiple tokens, this is an array right here. We passed in one token, you would just add more tokens. So if you look here, all right, if you look here, tokens, we just added 1. Okay, you could add 2. So if you want to add 2 tokens, you're 2. Token 0, would be like token that, and then tokens 1 will be token 1. Okay, that's how you add multiple tokens. Okay, so high level, the AI question is basically if you're going to be, you have to have AI analyze large sets of data, which is not a simple answer to that. You have to train a model to watch past price history to look at trends for discrepancies. And honestly, like AI can give you an advantage, but it's going to be pretty complicated. Like you're probably going to have some more success just by getting your hands dirty and trying some stuff. The AI stuff can give you a massive benefit here, but it's going to be super duper 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 complex. You're not just going to ask ChatGPT like, hey, what are the best trading pairs? But you could try plugging ChatGPT into DeFi Llama and be like, hey, find me some ARBs. I haven't tried that yet. What's the max flash loan providers can provide? It's usually in the multiple millions. How to determine borrow amount? Borrow amount is going to be determined by the smallest reserve in the liquidity pools. Change the chain from Ethereum to Avalanche. Well, that's where you have to essentially change the network here. Hard hat config right here. Again, research on arbitrage pairs. I would just get your hands dirty and try some stuff. Look at tokens. Okay, if we have an ARB path that involves more than one trade, what's the best way to handle that? Well, you're going to have to extend your arbitrage contract here. Okay. Once you receive the flash loan, you're going to have to break into this stuff. Instead of just swap on Uniswap, swap from SushiSwap, you're going to have to add your extra logic here. Okay, so how do you change the port if you have multiple stuff? So you can start your bot like this. You can specify the port. You can do port equals 5001 node bot.js, and you'll see it run on port 5001. You can try a second one like this: port equals 5002 node bot.js. And now I got two bots running, and they're on different ports. Did XRP news create arbitrage opportunities? Sure did. It sure did. Yeah, the video will be available on Mastery afterward. Yeah, I figured the ChatGPT thing wouldn't necessarily work with DeFi Llama. You could ask it other questions, though, like where have you seen price discrepancies or stuff like that. I don't know. You might have to get creative. So the smallest reserve liquidity pool is the smallest balance. So that's what I was saying before. With this, if you look at these, so you don't need any credit to do flash loans. Okay, this is what I mean. So like smallest reserve, in this case, 5,000 Shiba Inu, 2,000 WETH, 1,000 SHIB, 1,000 WETH. SHIB's the cheapest token. It's only 1,000 units of it here. So the maximum amount that you could ARB would be 1,000 WETH, because at this destination, 1,000, one WETH per one SHIB, and therefore you can only clean out 1,000 SHIB. All right, everybody, that's all I got for today. I got to go ahead and call it there. Great session this evening. Again, if you want to continue the conversation with flash loans and arbitrage trading, definitely, you can jump into the Blockchain Mastery Slack if you join that for the presentation tonight. If you didn't, we can definitely get you taken care of. And again, if you want the skills that you need to create, advanced coding strategies and become a real world blockchain developer, then I do have, again, a couple slots opening up pretty soon for the Blockchain Developer Mentorship Program. I'm personally inside of there, working alongside of you to gain real world blockchain skills over 3 months. So I put a link to that down in the, below this video tonight. Again, it's not something I'm really talking about very much publicly, like on my YouTube channel. I've only reached out to a very select handful of people so far, and I wanted to give you the opportunity tonight since we got a couple slots opening up since you joined the presentation tonight. So great session. That's all I got. And until next time.